So it's x times e to the...
Oh, I remember, negative x squared over 8.
Yes.
And are we given an interval or not?
Yes.
Okay.
So it's from -1 to 4.
Okay, perfect. So we're asked to find max min. In general, we're asked on a closed interval to find the max, the absolute max, absolute min. But I insist that you know how to determine the local max, local min, if there is one. Okay, so we are determining the derivative. So remember, this is function 1 and this is function 2. The first function prime is 1 times e to negative x squared over 8 plus the first function times the second function prime times the inner function prime. Is this okay so far?
Yes, thank you.
Okay, next. Of course, I will factor out e to negative x squared over 8. And let's see what we have. I will simplify in here. So there is a 1, and there is a minus 2x over 4. You know what I mean. I already simplified the 2. What am I doing? So now we have to find the least common denominator. And I can put this in the denominator. I don't need it where it is. So 1 over e to x squared over 8. And here the least common denominator is 4. So this needs to be multiplied by 4. So 4 minus x squared over 4. You know me, I will take the negative in front. So negative x squared minus 4 over 4 e to x squared over 8. And yes, immediately I will factor x plus 2x minus 2 over 4 e to x squared over 8. Is this okay so far?
Yes.
Very good. I need to find critical numbers. Critical numbers will not come from this being undefined because this is always positive. So the function is never undefined. But the derivative is never undefined. But the critical numbers will be positive and negative too, because I have to set the derivative equal to 0. So f prime of x equals 0. We have x equals -2 and x equals 2. -2 doesn't fit in the table. Only 2 does. Because -2 is outside, but 2 does. I will immediately study the sign of this derivative to see the signs here. Well, I don't care to even look at this. It's always positive. So this, when I plug in, let's say 0 on this side, 2 times -2 is negative with minus in front will be positive. And when I plug in 4, this is positive, but there is a negative in front. At this point, I'm almost finished with the problem, but I need to determine the function values at -1, at 2, and at 4. So with a calculator, so in y equals, clear whatever you have if you have something else. So then plug in x and e. I don't know whether you will perform the correct operations without the parentheses, but I like to be conservative on that. So I put parentheses. So second and table, I want -1, 2, and 4. -1, 2, and 4. So I see for -1, -0.88, for 2, 1.21, and 0.54. So therefore, now I try to make sure that these two work in sync, otherwise I know I have some errors somewhere. From this to this, yes, it's increasing, and that's correct. From this number to this number, yes, it's decreasing, and that's correct. And now, finally, I have to identify which one is what. So this one, -1, -0.88, must be an absolute min. It cannot be local because it's at the endpoint of the interval. This is the largest possible value, as you see, very clear. 1.21 must be absolute max, but also local. This is right in between, so it cannot be an absolute max, it cannot be an absolute min. At this point, I shouldn't even write anything, but let's do it. 0.54, nothing. Is this okay?
Yes, perfect. Thank you.
Thank
I
you.
just had an issue, I guess, differentiating it, which was obviously the first step. So everything else afterwards is kind of tricky to deal with.
Yes,
that
because
way.
if you can simplify it, then it becomes very difficult. Yeah.
Right. Thank you.
My pleasure. Thank you. Anything else?
I have one question.
Yes, please.
It's from Canvas, section 4.9.
You mean
Antiderivative.
WebAssign?
What's that?
You mean WebAssign?
Yes, WebAssign.
You're very good.
And it's find f prime to t, maybe f of t, yeah, it's f prime of t, equals 8 divided by 1 plus t squared. And then f of 1 equals 0.
Perfect.
Correct.
Very good. So because we have the notation f prime, then we are going to stick with the notation f of t. So we are asked to find the most general antiderivative for this. And the question is, well, 8 is 8. The question is, which function prime is 1 over 1 plus t squared? And once I find that, and then I will add c to it. So which function prime is 1 over 1 plus t squared?
Arctangent.
Very good. So now I know that f of 1 is 0. So arctangent 1, so 8 multiplied by arctangent 1 plus c is 0. But arctangent 1 is really asking us which angle has tangent 1. And there is only one angle that has tangent 1. And that is pi over
4.
Very good. So then we have 8 times pi over 4. We simplify. So then c equals negative 2 pi. So the function we are looking for becomes f of t equals 8 arctangent t minus 2 pi.
Thank you very much.
Thank you. So we were not really asked, I'm sorry, here this is the most general antiderivative, but we are given a condition so to find the unique antiderivative. Because I know I said the most general, that's how we start. I have to find the most general first. Any questions? Any questions? Is there anything else we would like to review? Our test is on Sunday. I wanted to start a little early, like 1:30ish instead of 2, if that's okay.
Do you have recommended things to review, or just pretty much go through all of
we
WebAssign?
reviewed everything. I just wanted you to pick any problem you want.
Okay.
Yeah, we reviewed everything, I thought. But again, it's up to you to say, yes, you know the list. What we just did, not 4.9, of course. So something like this. We looked at the Rolle's theorem and mean value theorem. We looked at L'Hopital's rule. We looked at graphing, optimization, and Newton's method.
So section 4.9 won't be on that?
No, 4.9 is with chapter 5. It has nothing to do with chapter 4. I don't even know why they put it at the end of chapter 4.
No. Thank you.
Thank you. It has nothing to do with chapter 4. Okay, any questions? So, what I think we should do now, so I'm looking to see if I missed anything no, the midpoint rule in 5.1, limit of the Riemann sum, I didn't miss anything there. I'm looking at section 5.2, I didn't miss anything there. I'm looking at section 5.3, yes, I did, which is part 1 of the fundamental theorem of calculus. That's our next step. And with some applications. And then we can move on to the last 2 sections. Okay, any questions again about test 3? Is there anything you would like to go back to? Okay, so you can stop me anytime if you remember something or if you come up with something, please stop me, okay? So we're trying to finish up one piece from 5.3, which is fundamental theorem of calculus, part 1. We know what is it all about, but how does it pan out? What does it mean, really? How do we illustrate this? So part 1, I'm going to write it again. It teaches us, or it shows, that differentiation and integration are inverse operations. Inverse operations. Okay, so what we're going to do, we are going to look at the following graph. Here's function f of x. I have an interval between a and b, of course. Now we know. And if I ask you, what does this represent? The integral from a to b from f of x dx. What will you say? What does this represent? It represents the
area.
Very good. It is the area under the graph. Excellent. Now imagine x. X is a number between a and b. Because I put x here between a and b, I will change this, but I don't want to change it on that graph. I'm just going to create the graph again. So this is a function f of t. Same function, but now of t instead of a, doesn't really matter. And this is x right here. And this time I will say, you know, x can be any number between a and b. And for this particular area, could I say that that is the integral from a to x from f of t dt? This area, I'm going to call it a1. Can I say that a1 is the integral from a to x from f of t dt?
Why not?
Perfect. It's correct. But now I would like you to look at this carefully, because I'm going to ask what happens with this value if x is a. You will say it must be 0, correct? The integral from a to a from f of t dt will be 0 because there is no width. But what if x is here now, let's say 1.5? What would be the answer? Just some number. What if I move x here and now the area is this? What will be the answer now? Definitely a different number. What if I move x here and I ask you to find this area, which is this? It will be a different number. So then what is really this that we just created? If for every x value I get a different number, what procedure is this? So I'm telling you the input is 5, you put it in here and you get a number. Then the input is 6, you put it in here, you get another number. Then the input is 7, you put it in, you get a different number. What did we just create here? What is this then? If we get a different number for any input that we put in.
Function.
Thank you very much. I cannot call it f. I have to give it a different name. Okay. So you're going to ask, fine, you created a function that has an integral in it. Wonderful. So what? This is how I can illustrate that if I differentiate this side and I differentiate this side, let's see what we get. On the left-hand side, I get g prime. No question there. I have a function. Whatever the function is, when I differentiate g, I get g prime. But let's see what we get here. And what really happens here. I am differentiating an integral.
Just f of t dt.
When the integral disappears, dt must go away.
Okay.
And we have to replace t by x because it's a function of x. And this is exactly what part 1 is really telling us. So we created a function in the form of an integral just to show that when we differentiate this integral, we get the function itself. Differentiation and integration are inverse operations. When I integrate a derivative, or when I differentiate an integral, I just get the function and nothing else. Now, this requires to be a number. This must be a number for the process to work. This, the upper limit, can be x or another function of x. And the process still works. So let's look at examples and see how this works. Let's start with a simple one. They are on page 394. I'm going to start really with number 7 on 394. The easiest I could find. So the integral from 1 to x from 1 over t cubed plus t dt. This question can only ask us to differentiate. You are not asked to evaluate anything or calculate anything here. So this is a function of x. You cannot be asked to do anything else but find g prime. Nothing else. Just to illustrate that when we differentiate an integral, we get the function. That's what this is used for. and of course it has other applications. We'll find other applications, but that's what we're trying to do.